All right, good afternoon everyone, and welcome to our last speaker of the day. We've got Dr. George Aranda. He's a lecturer at Deakin University in Education, works in science communication and has a background in psychology. Got that right? Awesome, and he's going to be talking to us this afternoon about your brain in space. So, all the best.
Unmuting myself. Oh, yep, there I am. Excellent. Thank you very much for coming and staying till the end of the day. I know there are exciting things on in the world, like an election today. Hopefully you went out and exercised your democratic right to a free sausage and maybe with some halloumi on the side or something like that. But thank you very much for coming. I feel a bit out of place at a presentation like this because I don't really have any really funky images of space or anything quite like that. But I hope you won't hold that against me. Now, my background, my PhD was in cognitive neuroscience. So I was really interested when I was asked to present here to really look at what studies have been done looking at what actually happens in the brain when we go to space. And I was surprised to find not that much conclusive stuff has been done. So I'm going to show you some of it as well as give you a bit of a background as to how psychology has or maybe more so hasn't been involved with the space race and those kinds of things, and also looking forward to maybe what psychology can tell us into the future. If you're a Twitter person, that's me on Twitter. If you're into books, I write a blog which is called Science Book a Day. So I'm kind of really into that kind of narrative and how science can be used in classrooms, in my education kind of practice, and in my science communication practice as well. Now, a bit of history. One of the things I found out doing some research for this presentation, that psychology wasn't really up in front as being part of the development of the space race, at least in the United States. Now, people had been sending animals up into the upper atmosphere by balloons or by rockets to really see if we could survive in the upper atmosphere or in space in particular. And so we have a history of sending lots and lots of different types of animals into space. And this lovely infographic here gives you a nice kind of breakdown from Laika, who was the Russian dog that was sent in 1957 into space, as well as cats. Our first monkey was sent in 1961. Rats, more cats. We have some spiders. We wanted to see if they could build their web like they do on Earth. The answer was yes, they can. Jellyfish, and we also have had, I can't read that from here. I think it's a salamander or a lizard or something like that towards the end. Now, you have to think, all these experiments were done just to see if we could exist, whether we could function in space, but not necessarily how well we functioned in space. And so, and you have to keep in mind that all of these kind of animal studies are done in conjunction with, in parallel with, say, the Mercury missions, which were first started in 1958. So 1957, we send the first dog into space, and then 1958, all right, let's try and send some humans out into space as well and see how they go. But up to that point, we weren't really interested in how well they were doing in space. It was just whether they could survive the process and whether they could be mentally competent in that space. And so we had with the Mercury mission, so if you've seen, The Right Stuff, great book by Tom Wolfe, pretty good film as well. If you have a chance to see it, I recommend you do. And so the idea with the people in The Right Stuff was that we were looking for men, in this case under 40, white, who had gone to university, had been test pilots, had engineering degrees, had science degrees. So we were looking very, very specific kind of people. And this is really kind of a layover from the Second World War, where we were looking for people who had that right kind of stuff to go into space, survive in a kind of a military kind of sense. And so this is, an outshoot of the relationship that NASA had with the military at that time. But as we've gone and progressed, these kind of missions, they were only in space for hours, maybe a day or so at a time. You had people in a single capsule to begin with and then a double. And then it's only as we've started to spend more and more time in space that we've really seen the need for psychology to be part of that process. And it was only until the 1980s that we started thinking about, at least in the United States, about having things like an International Space Station, having the space shuttle go up and spend extended time periods in space. And then we started to realise that, well, we probably need to do some psych testing of these people that we're sending up into space, because even in some of the history of science that I've read about this is that they weren't really interested in those getting psychologists in to do more testing, because of more bureaucratic reasons than anything else, because then we need need to pay more people to do more testing, and then we have to screen more people out that aren't satisfactory. And we need to keep these psychological profiles of these people kind of private, because it was really a patriotic kind of move to send people into space in the United States. And so having the idea that people were flawed, heaven forbid people are flawed, that go into space is just something that we couldn't do. And so it's with the advent of the International Space Station, the relationship with Mir, that we realised, well, if we're going into space for a long time, we probably need to get along. And so the idea of doing psych testing to see if people could interact with each other, if they could survive in a very artificial kind of environment for an extended period, became quite an important thing. Now, in 1998, there was something called Space Lab. And in particular, what I'll be talking about is NeuroLab, which was a 17-day mission in 1998, where they were asking a lot of questions about neuroscience and what are the effects of going into space. And there were, I think, 26 experiments. And rather than make you suffer through all 26 experiments, I thought I'd pick a few. They're a little bit more interesting than some of the others. So here we go. Now, space and the brain. Now, how many people have done like a science degree here or psych and that kind of thing, just so I'm not over-explaining things? Okay, so up here we have an image of the vestibular system, and the vestibular system is the inner ear, so if you've ever had an ear infection, you know how having that system disrupted really affects your balance and those kind of things. And the vestibular system really works by a series of hair cells that exist in those kind of arcs. So as you can imagine, there's a little circle, the canals that for moving forward, moving side to side or around, and we are able, with our eyes closed, to detect movement in that space. But we also have this crystalline structure here and the hair follicles that embed into there as well, and they give us the ability to tell with our eyes closed whether we're kind of leaning one way or another. And we have that kind of proprioception, that sense of self in that particular way. And so they were looking at how these hair cells are influenced by weightlessness. It's a fair comment, you know, you're going to be weightless, down does not always mean down, and what happens to these hair cells when there's no gravity? And so the study, I mean, this was quite a short-term study, 17 days, or 14 days of testing. And so what they found was that over this amount of time, the hair cells change, that the way they grow, and so some of these are also related to animal testing as well. They grow in different ways. And one of the tests they tried to do was the idea of, I knew I couldn't remember this word, which is gravito-inertial acceleration. So if you've ever driven a car really fast and you're kind of leaning in to it, or if you really get caught up in those computer games I did as a kid, you're playing a computer game and you start leaning to it and your partner's laughing at you because it's not really going to change anything. But for some reason you feel like it's better if I lean into the turn. And that's what that inertial kind of thing is. And so they've done a series of tests looking at people in space with that weightlessness, because basically you've got no down, you've got no sense of gravity, and how does that affect this crystalline structure here? And so the study showed that at the beginning, astronauts were really bad. That tilt factor, it felt different to the actual way that they were leaning. And so over time though, over that kind of 2-week period of the testing, it was shown that we could adapt, that our brains are sufficiently pliable to actually start leaning in the right way in a response to that kind of inertial kind of activity. And it's also quite interesting because when astronauts get back to space, get back to Earth, after extended periods, they have that kind of, you always see them get out of the thing kind of lurching, and that's got to do with, the muscles and bones and that kind of thing. But it's also because they have a hypersensitivity to that tilt for being away from Earth and its gravitational pull for all that time. So I thought that was quite an interesting one. The second one, which is this lovely image here of the person sitting with the ball in front of them. And so it's the idea that we have a mental representation. So if you can imagine, I don't know why you would do it in real life, but if you can imagine doing it, if you closed your eyes and you threw a ball up into the air, you would know based on experience that you'll probably catch it at a certain time, depending on how fast you threw it. Whether you have the skill or not to catch it with your eyes closed is a different thing altogether. Right, but as you can imagine, over time, if we spend more and more time away from our, you've spent 30 years or however old you are, accumulating all this experience with gravity working in a particular way. If you're in space, how does that change? How does our expectancy of things falling, that inner representation of that phenomena, how does it change? And I'd like to say it was really interesting, but it basically was about the same. we could again adapt to successfully catching things thrown at different rates in space. Our inner representation wasn't changed. Although you could say, well, is 2 weeks a long enough period to really examine that kind of a question? I mean, how long? We now have people, I think it was those twins who just came back, was it last year? Spent 365 days, one of them in space. I mean, how would his representation have changed over that time or even longer? The second one I do quite like, and it's related to the idea of those hair cells again in our vestibular system. So we all have had that experience of maybe sitting on a train, and you're sitting on a train, you can see the train next to you, and then the train opposite you starts moving, but you feel like we're moving or something like that. We've all had that experience before. And it's really that, because our vestibular system provides us with a certain amount of input about where we are in time and space, and our eyes give us other input. So you can understand that car sickness. So if you've ever read in a car for an extended period of time, you're going to feel really woozy, but the way that you resolve that is by looking up around you. You provide yourself with a horizon or something like that. Seasickness is kind of the same kind of idea. And so what they were testing in this particular study was whether those changes that occur to our vestibular system, no matter how small or different, how would they be influenced by that sense of that train kind of moving? And so they did some studies where they actually provide like a virtual tunnel that these astronauts were virtually moving through. So they looked at it on a screen essentially, but they still got that sensation of movement. And basically, even though the vestibular system had changed and was oversensitive in some situations, a visual system is really still very good at overcoming that kind of that feeling that we have. Now, one thing I was quite interested in was how do our brains develop without gravity? You can see a theme here, they're all about gravity. And so they did it in that, and in the NeuroLab, they sent a number of different animals into space, and they were at various stages of development. So they sent like the rats that had just been born, they sent snails and slugs and all these other kinds of things to look at how they existed. Now, remember that crystalline structure I talked about earlier on? When they looked at it in snails, what they found was that snails grew larger crystals. So these crystals are related to how we perceive gravity. And it was seen there was an overdevelopment in snails, which is kind of an interesting finding. What that will actually mean into the future is another question. But then they looked at larger species, such as rats, and they found that the actual neurodevelopment of rats was it really impaired the growth, and eventually these test rats died. But it does show that at a certain level within our brain, we can cope without gravity up to a certain point. But after that, when things start to get more complicated, like the heart pumping around the body, issues of blood pressure and those kind of things, they are influenced more by weightlessness. And so this is something that we'll have to look into the future with, you may have read science fiction books where the idea of generational starships exists. You might have seen WALL-E, where you've got a whole society moving through space. And we'll have to look at how these things influence, people being born, people growing up in space, and even if we develop artificial gravity by whatever means, these are things that we'll have to look at. And these studies do indicate that there may be, like, you may have heard there's a critical period with language and that kind of thing, that there may be a critical period where gravity is really important in the development of humans and animals. So I thought that was an interesting finding. Now, with my background, I was largely involved with doing EEGs, looking at what an EEG is. So it's an electroencephalogram, and you've probably seen them on TV before, where a person's got kind of like a swimming cap on, and they've got all these sensors that are attached to their skull. You may have even been in one of those experiments. And they basically measure electrical brain activity. And this is a system, I love technology now. You can get a Bluetooth EEG system. You can even get them to play computer games. I'd love to afford one, let alone buy one. And so they've managed to take some EEG data in space and see what those changes were. But at the moment, it's kind of a difficult thing to really interpret. So they did show changes in the brain. They showed differences in alpha levels in the visual parts of the brain. But the significance of these things is really still Hard to tell. Within our brain, we do have blood that flows around the brain. Oxygen needs to go to those parts of the brain. So an fMRI measures changes in oxygen in various parts of the brain. And as you can imagine, in weightlessness, that movement of blood around the brain would be influenced by gravity as well, just like the movement in our heart would be. And so there are differences there, but it's difficult to say, is it the stress? Going into space is quite a stressful experience. Staying in space can be somewhat traumatic, well, weird, more than traumatic. And so the studies in this case have shown that there are differences in the brain based on EEG, but what the causes of these changes is really speculative at this point. And whenever I go to school and I talk to kids about science, they're really disappointed. They think that science can answer everything. And when you tell them, I don't know what the answer is, they're really disappointed by that. But I hope you're not disappointed, is all I'm saying. That we just don't know at this point. Now, in preparing for space, and as I said, we're really dealing more and more with psychology in terms of relationships, about our environment. And so I didn't mention this before, but as I don't know which space mission it was on. It might have been Neuralab or one of the space labs, where they did experiments, but the people at ground control had filled the whole day of these astronauts from the moment they woke up to when they went to bed. Their whole day was mapped out. And if all of us in our workplace, when you've got your whole day mapped out and you just look at your calendar and just meeting after meeting after meeting after meeting, that's going to be a sucky day. And so if you're, in space for an extended period away from your family or away from functioning toilets and that kind of thing, you're going to get a little upset if someone's filled your whole day with that kind of stuff. And they went on a sit-in. They just basically sat in, looked out the window and didn't do any work, which in my own job I feel like doing from time to time. But when you're going around the Earth and you can't even look out the window for 5 minutes, you're going to ride in some way. And so it became more and more important for ground control to give our astronauts in space time to watch a movie. Maybe not The Martian, but watch a movie at any rate. That'd be terrible. Give you time to watch a movie, to have a chat, to look out the window, to Skype your family, to do those kinds of things. So as we've had longer and longer times in space, we're more mindful of having constant communication with your family. They even have little boxes sent up with Christmas goodies in there and that kind of thing to make you feel more at home. And they've even redesigned so the cockpits and areas within the International Space Station, so you can just sit and look out the window. And if you've seen the photos by Chris Hadfield where he's taken photographs of different parts of the Earth, it's an awesome book. And so we're much more mindful of the psychology of keeping people in space for that extended time. On the other side of this, we've also spent a lot of time, decades, looking at building these kind of habitats in Antarctica, in deserts around the world. Off the Florida Keys is this underwater one there. And all these kind of things are really looking at the machines as well as living in these kind of extreme and isolated environments. So you could imagine living underwater in the Florida Keys for months at a time and you don't come up for air will give you that real sense of isolation, that real sense of the alien. You imagine you can't see the sun rise or set for months at a time is going to have a certain effect on you. In Antarctica, they have again explored that kind of isolation, that endurance that people have, but also testing habitats. So the idea that we can have an inflatable habitat that can be erected in less than an hour and taken down so that people can live in these kind of hostile terrains and test the equipment that we're going to use. And I think that's really important. And then again, the underwater environment gives us this nice idea of how things work in low gravity. And again, that kind of sense of distorted feelings of what gravity's like. And I think more and more into the future, we're going to get into this kind of complementary human-computer interaction that we need to use, as well as this human-robotic kind of interaction. So at the top here is this idea, this is an artist's mock-up of mining asteroids, that idea that we'll go out and mine asteroids one day. I think there's been some question of the economic viability of doing that, but it's something that we reach for anyway. And these ideas here, you can't really see it in this shot, but this is a car where the front part is a robot. And so it's already kind of used to actually move the car around, and then from the actual command module, you can actually then robotically move these hands to actually do fix up aspects of the space station. And this is This is a two-armed robot, which has these kind of limbs on it, so when you reach out for something, you're not trying to use these little claws that are completely alien to your kind of embodied cognition and psychology. It's a realistic kind of way to do things in sometimes what feels like an disembodied way. If you've ever tried to do anything remotely, like, fly something. Well, I like the drone cameras now with got the virtual reality kind of glasses. I think that's really cool. But to do other things can be a bit more problematic. Now, a more recent study that I came across was this one, which is what cosmic rays do to the brain. I thank The Guardian for this awesome picture. And if you go online, you'll see a lovely 1-minute kind of summary of this study. And so these rats were exposed to high energy particles that are quite similar to what they would expect to feel in space. And so they did this for 6 weeks, and then they had their learning and memory examined, so they were given some memory tests, pulling a lever in response to different things, memory as well as the way they explored the environment. And what they found was that they just got confused, whether they couldn't remember what they were supposed to do or just have a moment of, what am I doing here? Like when you open the fridge and you just look at it, I don't remember what I was going to look for, and you close it again and go away. And so you can imagine at a rat level, that's one thing. But, when you're, in command of a space station and what was I supposed to do? Close the hatch. Oh, close the hatch. That would be a great thing to do. And so this is really something that would need to be considered. The idea of, if we do go to Mars, it will take a few years to do that, 2 to 3 years, I think. And so the idea of shielding ourselves from these high energy particles is quite an important thing, whether we take it in terms of whether it's a shielding issue or whether we have to think about the way that we get people to interact with each other, or we rely on remote control for certain periods of time, is something that would need to be considered. And I thought I would end with the future of space travel. So depending, if you're Elon Musk or whoever you are, and the idea of going into Mars is your thing, it's something that we'll need to consider more and more. So we have the direct effects of going into space, but whether you have some sort of habitat like that where you can grow, looks like fir trees or something like that, or the Mark Watney growing potatoes out of your own kind of stuff, we will have to consider what kind of things will influence us, our nutrients, exposure, the drinking water that we have. How these will be all things that influence our psychology and the way our brain works at an everyday level. And I think I'd like to leave it there. Thank you very much.
We do have a little bit of time for questions, if anyone has any questions.
Yep.
There's a lot of research at the moment about the gut-brain connection, and so I'm wondering if that's making its way into some of this research in space as well.
So the gut-brain for things like?
Well, like when you're talking about the mice that died when they were up there, like could that perhaps be as well, like the microbial environment that they're in is less or different than what you would find on Earth, so that could also be affecting the brain?
Yeah, I'm sure that could be part of it. I mean, because we're not setting up a really hospitable kind of environment. So I think that would probably be part of it. I mean, because we live in a certain way to allow our microbes to exist and do the things within us that are usually quite good for us. But I guess that could be part of it. I guess they were looking at weightlessness in particular. So yeah, but I'm sure it's all a connected system. So.
I might have missed you mentioning this because I unfortunately arrived a couple of minutes late. But I have read somewhere that somewhere in the 50s or 60s, a piece of human brain was sent into orbit on something. And I read it somewhere and I've never been able to find the reference since. And I wondered if you maybe knew anything about
I
this.
didn't know. I don't know about that one. All I know is about the Einstein one where bits of his brain disappeared after he died and that kind of thing. But I don't know about that one in particular.
If you ever do find any reference to this, I'd be very curious to know.
Conspiracytheories.com or something like that. Yes.
So just on your study there of memory.
Yes.
The studies about memory that you just mentioned.
With the rats?
Yes.
Yeah.
Would that rule out a trip to Mars, say in the 2030s, because we're not quite sure what will happen to the astronauts between now and then. So even if we have the spacecraft to do it, we wouldn't want to try.
Yeah, I guess that is the implication of long term in space. So I guess, yeah, that would be a direct thing. How do you resolve this? Do you make the shielding on the ship more thick? If it is, it's going to be heavier, it's going to cost more to send. Do we put people in stasis for a little bit of time and run ourselves on autopilot, which isn't great compared to the person with the Tesla car who the AI went a bit haywire. So, do we want to leave ourselves in, well, it would be funny if Tesla were the one who actually sending us into space into the future. But yeah, no, that's a big thing that we'd have to actually figure out. And whether it's enough to just shield our brain from that kind of thing, in a magneto helmet kind of sense, or in some other way. Alfoil, yes, that's right. I'm protecting myself. Yes, no, that's it.
More questions?
Damn it.
There have been some reports in, I think, the 80s and 90s of astronauts basically, while they were up in space, on extended flights, effectively going on strike and saying, no, I'm not going to do what you want me to do. It didn't seem bad unreasonable in some ways.
Yeah.
It happens every day on Earth,
Exactly.
everywhere. But in space, have there been any more reports of that kind of thing? And I suppose the talking about rest time to astronauts. Has that helped? What other things do they do to try and alleviate that?
Yeah, no, I haven't heard any more examples of strikes in space, and and it is completely understandable if you're being mistreated in your workplace, why not strike? And I guess, yeah, I did read a lot of measures that were introduced just to make space a more interesting environment, and also to make it more personable. You can bring your own things, you have frequent connections to your family, and I think that the idea of those science communication, those public engagement kind of things make it a bit, because I guess at a certain level we're interested in the hard science that we can do in space, but at another level it's also about public engagement and outreach, and God knows that NASA needs help with its budget a lot of the time, so doing these kind of things to reach out to schools, getting astronauts to interact, and being someone like Chris Hadfield who did those experiments in space and actually YouTubed a lot of it and that kind of thing, does make your day a bit more interesting than doing your regular kind of things. And I guess a lot of, I didn't mention it, but other research has been done to look at circadian rhythms, so those kind of processes that allow us to have a 24-hour cycle. So sleep patterns and research into the comfort of people, whether, the use of plants. I think they put a 3D printer into the International Space Station. They've been able to make espressos in space and that kind of thing. We're all Melburnians. We need a strong, skinny latte on any given day. So, why not in a space as well? So, space beer. Yes, that'd be great. So I think they've done a lot to kind of alleviate the habitat issue, and just introducing a more realistic day-night cycle and just having fun has done a lot of good. No more strikes since then. Yay. At the back.
That made me think of one of the early habitability studies for Skylab and future space stations. It basically ruled out rotating, creating creating a gravitational environment by rotation.
Oh, 2001 lied to me.
And then it might even have been Vanderbilt around himself who said, be realistic, nobody is going to like living in that. Nobody. And so they abandoned the idea of rotation as a feature.
Oh.
Gone to habitation. So
Wow, I didn't know that.
I was planning to get much myself.
Okay, because I think it was in Elysium. Was it? I think there was a rotating element to Elysium, I think. Hi.
You mentioned that there's greater recognition of the value of psychometric testing.
Yeah.
I was just wondering what sort of traits or qualities they're looking for that's predictive of someone being able to cope in space.
Wow, that's a good question. No, it is. It's
I've spoken to it anyway.
I didn't have a chance to look at what kind of psychometric testing that they'd done, but I presume they would do something like a personality and stress kind of inventories and those kind of things. But, I had a great quote. about one of the early, because they did have psychiatrists in the early screening of people going into space, but there was no consistency. They just got 2 psychiatrists in, they interviewed each of the applicants separately, and they said, yeah, he's good, yeah, she's good, whatever the case was. And there was no write-up. So people were going back 10 years later saying, what were the qualifications these people needed? And then, well, I don't know, we didn't write anything down. So it was really up to a person's opinion. But one of the quotes that came out of it said that one of the people was asked, how do you cope with stress? And can you give me an example of how you dealt with it? And he said that basically he was a test pilot, he was in a plane, it went into a kind of a flat spin and was out of control. And he said, oh, all I did was I got the manual out and I flicked through it and I read the part I needed to read and I righted the plane. Which is a great story. And it does indicate that stress, I think, would be one of the things that you would need to be able to take into account. But the more modern testing, I think, would take in like personality inventory, a bit more sophisticated than the one that's done in businesses. MBTI, which my wife always quotes to me what her MBTI is, and it's like, no, it's got no more statistical accuracy than your horoscope does. It's true, unfortunately. But there is one called the NEOPI, which has got a lot more kind of consistency to it. So I think it would be that ability to interact with others would be a very important one, as well as being culturally sensitive, because I did remember there were some issues about the Russians and Americans interacting, because the Russians for a long time had actually been psychologically screened and had training for interpersonal relationships and that kind of things, whereas the Americans had not. And I think there was an incident where they shut Mir so that they couldn't interact for a period of time. Can anyone confirm or deny? But I think that may be the case. So yeah, I think personality, ability to play well with others, and those kind of cultural sensitivities definitely come into it. Yes?
So just to follow up on that.
Sure.
That question, what you've been showing here is around, we can talk about probably long-term space missions. With space tourism, so either a suborbital flight or, maybe a space hotel for a few days or whatever in low Earth orbit. Do you need to take into account any of these type of things?
Yeah, I would say for suborbital flights and that kind of thing, I think if you're spending hours in space, it's not going to be that much of an issue. But yeah, I think definitely if it's going to be a hotel in space, I'm sorry, I've just had an image. It's got to have a casino at the bottom. It's going to be great. And then we have cognitive issues. Just keep betting. It's fine. Don't worry. But I think any time that we spend more than 6 months in space is something that we would have to consider the viability of the protection of people and their cognitive issues, and whether it's you have to come back to a certain place to de-space yourself before you go out into the public would definitely be something that would have to be considered. Yeah.
Any more questions? Awesome. Well, thank you so much for your time. I really enjoyed that speech, learned a lot, and everyone join me in once again.